My name is Megan Cheng, and my partner Alison, Fung, and I created a web app called WattWatcher-AI. This app is created to analyze telemetry data and detect electrical and motor faults while providing quick solutions and fixes. It was first made to help the first robotics competition teams with quick diagnostics with wiring issues, but it can also be applied to any timestamp dataset containing current, voltage, and rotational speed. Now, moving on to how we collect data for FRC robots. The PDH, or the Power Distribution Hub, is the electrical switchboard for the robot. It centralizes power management and protects the wiring. It also gives teams real-time insight into how much electrical load each subsystem is drawing. It gives us the real-time telemetry, firmware updates, and the CAN bus access. The telemetry data includes bus voltage, total current draw, total power and energy consumption, individual channel currents, temperature, and channel status. You can get all this data from the USB-C port on the PDH.
We used Visual Studio Code to program our entire project, which was done in the programming language Python. Within our Python, we programmed in a virtual environment, which is a specific type of environment that isolates the project from the rest of the computer's operating system. This ensures that our project doesn't interfere or conflict with any other projects that could be contained or being run on the computer. Next, in order to implement our project as a web application, we use the application Streamlit, which helps us create a more streamlined, clean display and website to display our project in. Our project has two tabs, an Analyze Telemetry and a Generate Test Dataset, and these will be displayed more in a second. And here is the Generate Test Dataset tab. Next, I'll show a demonstration of our application. So our application is first run through GitHub, so it's completely open source. Then you can copy the GitHub command into the terminal, and that's all you need to do after installing the entire thing and following the instructions in the GitHub's README. So this command right here will trigger the virtual environment. As you can see, it's kind of making sure it can bypass and completely integrate fully, and then it will make sure that your computer has all the requirements needed to upload the video. Now you can see how our application works. So first we'll go to the Generate Test Dataset tab, and we'll choose the amount of normal points and the number of anomalies we'll want to use. And this is so that anybody who doesn't have a dataset but wants to test our application can use it. Next, we'll download this as a CSV and drag and drop it into our Analyze Telemetry tab. This will run the anomaly detection and finally show the flagged anomalies, what you can do to possibly fix it or suggestion, as well as graphs that show the trends in each thing. With the creation of WattWatcher-AI, Megan and I hope to create a telemetry tool that's easy to use, easy to access, and available for people around the globe to use in order to analyze their electrical data.